computer. Okay, so now it is recorded, so that's good. So once I finish the meeting, I will produce it. Now I'll post it in our Blackboard course, right? So you guys can review the video over the weekend. Get ready for the actual exam. So let's get started, right? So first of all, we're gonna let's log onto our book. Now open this review for exam number 1 and go through one by one, right? Start with the problem number 1. Okay, on the problem number 1, so this is a typical question that we use in a table to estimate a limit. I'm gonna work it out step by step, right? And you guys can take a look at this question really quickly, and I give you a couple minutes, think about it before we go over the solutions. Okay.
Professor, for some reason I
Yes.
couldn't hear you.
Yes. Actually, I let you guys think about it for a minute.
Oh, okay. Okay.
And then we're gonna go over this together, right, in a second.
All right.
Okay, very good. So yeah. So since you mentioned that, so let's get started. So basically, we try to evaluate the limit for this function f of x equal to this, right? So we're gonna so basically we're just gonna find out what is the y values for each given numbers here, right? So basically we're gonna find x when x equal to 3.002. Then what is f of 3.002? And that's gonna be replacing the top and bottom and by 3.002, right? 3.002 and to the third power minus 27, that's on top. On the bottom is going to be 3.002 squared minus 9. And the quotient is our result, right? Let's see what that is. Also, I'm going to show you, if you want to use some technology to do this, you can do that, right? I'm going to do it in Excel, right? And that's just going to fit in some of the blanks right here. You guys can see the Excel file, right?
Yeah, I could see it.
Okay, very good. So first one is x equal to 3.002. Okay, so f of x is x cubed minus 27 over if you guys want to try this, you can try it yourself too. You just want extra things to have, you know. So basically that's gonna be this in parentheses, this number raised to the third power minus 27, okay, and divide by the cell number would still be 2. There's the second power minus 9. Like so will get a result for us, right? So this turned out to be 4.5015. So that's the number we're looking for. So 4.5015. So this goes in here, like 4.5015. First number here. We're also gonna find the rest of them. Again, I'm gonna automate this, right? So I'm gonna use a Excel to get all the numbers here on this side, right? So 3.001, 3.005. So this is getting closer and closer to 3. Okay, because we're looking for limit when x approaches 3. So now go back here. I'm gonna put in the numbers 3.001, 3.0005, and 3.001. So this is getting closer and closer to 3. Now I'm double check the numbers. Okay, it's all good. Now watch. So in Excel, once you do one of the calculations using the cell, actually you can just drag it, get the rest of them. All right. So that's one way to automate all this work, all these detailed calculations, right? So you see this trend right here. As you can see, this is approaching 4.5, right? From the left. This is from the right. Okay? This is approach 3 from the right. Say 3 is here. Now we approach 3 from the right. And the limit when x approaches 3 from the right, it's 4.5. Figure out that. Now we're gonna, I guess I will just copy the title. And then the work on the left hand side, right? Left hand side, we also need 4 numbers. So let me just quickly format this. Okay. So in the first exam, right, if you guys want to use like what I did here, use Excel to do it, no problem, right? You can, if you look at this, have a similar problem, you want to go with Excel, feel free to do that since I show you guys how to do this. Okay. All right, so go back here. So let's copy all the numbers. So 2.998, 2.999, 2.9995, 2.9999. So again, the trend here is getting closer to 2.98. Yeah. 2.999. L2, let's see. 2.9995 and 2.999. 2.995. Now one more time, you put equal sign here, right? And we're going to do this number raised to the third power, right? Minus 27. And then divide by the other one will be F2 raised to the second power minus 9. Okay. And again, keep enter, right? And drag it. As you can see, this is approaching 3 from the left. If you look at it, this number is getting closer to 4.5 as well. Right, so limit when x approaches 3 from the left, it's also equal to this. Right, so that means the two limits converges. Right? They both become 4.5. That means our answer here will be 4.5. The limit as x approaches 3 will be 4.5. Any question about this? Okay. Again, the key thing here is to find out what is the limit when x approaches 3. Very good. No questions. Yeah, let's go back to the next question, right?
Professor,
question. Sure, yeah, go ahead.
I have a question. I'm a little confused because there are some questions that we can do like direct substitution, like I can take the
Yes.
3. And I'm a little confused. How do I know which ones I can do this and which ones I need to do the table?
Okay. If you do direct substitution here, what do you see? Very nice. Let's see, right? over this x squared minus 9. So if you direct substitution, let's try direct substitution. And if you see 3 goes in, right, you got 3 cubed minus 27 and 3 squared minus 9. Then 3 cubed is 27 minus 27. Okay, and then over 9 minus 9. And this is 0 over 0, right?
Yes.
It's undefined. So that's why direct substitution doesn't work here. And that's why we come up with this method, this table method. This is called a table method to estimate the limit. Yes.
But
Makes sense? Sure. go
Yeah,
ahead.
it does make sense. But how, like, when I'm looking to the question, I recognize on which method I should use?
Okay.
You can't, you have to try it.
Right, exactly, right? So as Ellen just pointed out, if direct substitution doesn't work, then you're gonna try some other method, right? We also have, this is first method, method number 1, method number 2. have-
Okay.
Right, we have like a rationalizing, right? Or canceling
It
method.
was like the backup, like if
Right.
it doesn't work the first one. Okay.
That's
Right.
right. So canceling method actually works here. If you factor the top and bottom. X approach 3. So if you factor the top, you get x minus 3, x squared plus 3x, right? Now, on the bottom, we get x plus 3, x minus 3. Okay, and cancel that, right? Cancel the common factor. Now you can do direct substitution after you redefine the function. So that's why you got to be a little bit flexible, right? Depends on different cases. You always try this one first. If the direct substitution fails, then you have to try something else. Always some method available to solve the problem, right? You just have to try it. If you plug in a 3 right now, you're gonna get 4.5. But a table is also a very good method, it's a very good way to estimate the limit. And you also need to know how to do this right, step by step. I also show you how to automate all this work, right? You don't have to do this detailed work. You can let Excel or some other like technology to help you. But you need to know all this detailed information before you can comfortably apply any technology. Okay. So this is question number 1. Actually, the answer is good. Now let's look at question number 2. Okay, you guys try that for a couple minutes, right? Before I show you the solution. I think that works best. Yeah. Think about it. See if you can. So again, we try direct substitution first, right? Anytime we want to find a limit. So if we plug in 30 here, you can see radical on top is radical 36 minus 6. On the bottom is 30 minus 30. And it's 6 minus 6 over 30 minus 30 on the bottom. So again, it's 0, 0. So it's called indeterminate form, right? It's not determined. So that means direct substitution fails. And we're going to try something else, right? Substitution fails. In this case. Then this one, since we see the square root, so we're going to try third method called rationalizing the numerator here. We're going to rationalize the numerator, meaning we multiply the numerator by the conjugate, right? So let's copy the limit here, which is 30, and get radical 6 minus 6 in the parentheses, on the bottom in parentheses, and we multiply the conjugate radical x plus 6, adding 6 over radical x plus 6, adding 6. Now we basically create a what we call this. This is kind of like difference of two squares. So it's like a minus b, a plus b. So this becomes limit x approaches 30, and it's going to be radical x plus 6 squared minus 6 squared, right, on top. On the bottom, which stays as is. This one stays as is. Now you just simplify the numerator, and we're going to get x plus 6 minus 36. 36, denominator stay as 6. So it's x minus 30 and radical x plus 6 plus 6. Now this is actually, this thing becomes x minus 30. So this, we're going to cancel both top and bottom. So right here, we cancel this. This get canceled, this get canceled. Common term, right? So this will become 1. So eventually we get a simplified version of this function. So it's 1 over radical x plus 6 adding 6. Now we can do direct substitution. So once we rationalize in the denominator, the numerator, then we redefine the function, we convert it to something else. Now direct substitution works. So it goes here. Get a 1 over radical 30 plus 6 adding 6. So this is 1 over 6 plus 6, that's 1 over 12. Yeah, so the answer is just going to be 1 over 12. Do you guys have any question about this? Okay, let's check it, right?
No question.
Answers. No questions. Very good. And question 3. Yeah, so what do you think? Anybody want to share your idea on how to solve this?
You factor it up
Yeah, exactly.
and cancel out like terms, then plug in the 2.
That's right. Very good. So let's quickly do that. So you guys are very good at this. That's very good. So basically, if you do direct substitution one more time, you're gonna see 0 over 0 again. So it fails, right? So direct substitution fails. So we got to try something else. Okay. So meaning we get to try factoring and then also redefine the function at the same time. Okay, so let me share the screen. So right here on the top, let's just copy this. So 2 on the top, we will factor into x minus 2, x minus 1. And the bottom will be x minus 3. No, x plus 3. Right? X minus 3. Now by factoring, we'll be able to cancel the common factor x minus 2 and also redefine the function. So now we have the new function. We also eliminate this 2, right? Eliminate 2 on the bottom, so we can do this direct substitution afterwards. So it's x minus 1 on the top, x plus 3 on the bottom. Now, if you do direct substitution right now, so 2 goes in, 2 minus 1 on the top, on the bottom is 2 plus 3. So the answer is 1/5. Okay. So that's basically how you find a limit in this scenario that you have to redefine a function. All right, any question about this? Okay, so it's good, right? The answer is good. Okay,
So
next
hold on, hold
question. Sure, yeah. Hmm?
So we plug in 2 for
Yeah.
x.
That's right,
Okay.
Thomas. We plug in the 2. After you cancel the common factor, right? Only after you cancel the common factor. Like we cancel x minus 2 first. Then you replace x with the 2.
Mhm.
Make sense?
Okay, thank you.
Okay.
Yeah, very much.
Okay. So again, I will produce this video, right? We call this video, and then I'll post it in our Blackboard course. I just label that exam 1 review, right, in our Blackboard course. So over the weekend, if you guys want to, while you're working on your version of the review for exam number 1, you want to use this as reference, feel free to do that, right? It's good. Okay, so now problem 4. Now we have this. Okay, so we have this, and now since we learned the limit, also the derivative, anybody figure out what do we actually do here? What do we actually try to find out in this case? By doing the left-hand side limit, right-hand side limit.
Do you find out the absolute value of -20 to the plus power and then
Mhm.
plug that in?
Mhm.
Well, you'll find that they don't approach the same value because the x will be positive or negative, but you'll get the same y value. So their limit will not exist, but you'll see exactly why and where it is not existing.
Yes, exactly. Yeah,
Yeah.
that's very good. Also, we actually
Thank you.
find out, yeah, very good. Both of you guys, a very good response to this. And also, one of the interesting thing is we actually try to find out the derivative of slope of tangent line on the left hand side. So this is basically slope of tangent line on the left. X approaching -20 minus on the left. And this is slope of tangent line on the right. Slope of tangent line.
Negative infinity.
Yes, exactly. No, it's not infinity though.
I mean,
We're gonna
Wait,
find
what?
out in a second. They're not infinity though. They actually, one of them is +1, the other one is -1.
Really?
Right.
Oh, yeah.
Yeah, right.
Never
You're
mind.
gonna see that in a second. Yeah. So eventually you will see these two does not equal to each other. That means, one of them will be this. So this is 20, right? So -20. Okay, so let's say this is -20. One of them goes like this. This is 1. The other one goes like this. This is -1. And they have a big break here.
Excuse me?
Is your screen moving? Because we can't see nothing.
Oh, yeah.
Yes.
Okay, very good, very good. I forget to share that. Yeah, this is basically our chart rule, right? So this is basically the limit as x approaches -20 from the right. This is right hand side. This is left hand side. And then they don't agree with each other. That's why. So in this case, we know that the derivative does not exist at the equal -20. So this means based on these two, we know that derivative does not exist at x equals -20. Yep. So Yeah, so let's analyze it one by one, right? So you'll be able to see what happened here. That's why I draw this right here. So if you look at the first one here, so x approaches -20. So let's draw a number line, right? -20 here. It's right here from the right-hand side, right? So you're gonna look at the. So that means approaches -20 from the right. This is the right-hand side. Is this positive or negative? X absolute value of x plus 20. Is it positive or negative? Anybody find out that?
So
Positive.
It's positive, right? Because you want to really use a number that will be something like this. So again, a number very close to -20, but it's actually slightly bigger than -20. So if you add 20 to that, you get a positive number, right? This is positive. That means we can simplify this by getting rid of the absolute value. So do here is yeah, just make it x plus 20, right? Now on the bottom stays as x plus 20. That's why this drawing a graph will help you, visualize this. Why this is positive? Why we can just get rid of the absolute value sign and simplify this, right? So after we get rid of it, then we simplify this, it becomes 1/1. So it's 1. So limit of the 1 is 1. That's why you see I draw this graph here. So that means slope of tangent line for all of this here. So approaching from the -20 from the right, it's positive 1. That's why I put 1 here. -1 here. And the second part approaches -20 from the left. This is the left, right? The left is from this side. Okay. If you try to visualize this number, you want to really put a number here, to represent what that notion is. It will be -20.000. But if you look at this, right, when this is the number, what happened to absolute value x plus 20? First of all, is it negative or positive?
negative.
Negative, right? Very good. It's negative. So that's very important because since it's negative, so we want to make sure it's positive. So we have to, when we get rid of this absolute value sign, then we have to put negative sign in front of it. 2 negative will turn into positive, right? Because anything comes out of the absolute value sign, it's positive. Has to be positive. So we just add a negative sign in front of it, and we can get rid of it, right? Get rid of the absolute value sign. And we cancel the common factor here. So this, right? And it just become -1. The limit of -1 is -1. So that means limit when x approaches -20, they do not converge, meaning these 2 points do not connect, right? That's a big gap here. And that means limit does not exist in. And basically what they try to do here is this part is coming from this. So let's say our function is f of x equal to absolute value of x plus 20. Yes. Now you know that it's an absolute value function. So this graph look like this. So let's say this is -20 here. It will look like this. And that actually tells us that's the corner here. So from the left-hand side, the slope of tangent line is -1. On the right-hand side, slope of tangent line is +1. Okay, and they do not converge. They do not agree to each other. That's why at the corner it's continuous, but it's not differentiable. So here is not differentiable. And these 3 statements actually proves derivative does not exist at x equal -20. So that's why the whole purpose about this analysis here, you can consider this as analysis, is the function, this original function f of x is not differentiable at x equal to 20. Because it's corner, right? Same thing happened to cusp. I think one of you guys mentioned that at a cusp, it's a negative or positive infinity, but the graph looks slightly different, right? This is the cusp, and on the left-hand side is approaching. The slope of tangent line is negative infinity, and then from the right-hand side, the slope of tangent line is also negative infinity. So that means at that cusp point, it's also not differentiable. Right there, it's not differentiable. Yeah, not differentiable here. And that actually helps us understand the relationship between the continuity and differentiability, because it's continuous everywhere, right? For both corner and cusp, but it's not differentiable at that given point for those two phenomena. Yeah, so that's basically problem number 4. Any questions about this? Yeah, that was good. Your answers are good. Next problem, problem number 5. Yes. So it's about the piecewise function, right? So you're going to sketch the graph of the following functions, use it to determine the following limits. If a limit does not exist, type DNE. Okay. So again, we need to sketch the graph first. So let's do that one by one, right? Copy this. Okay. Let me share the screen with you. Forget to do that last time. Okay. There it is. Yeah, it's right here. Okay. So we have a function 3p. Okay. So first thing we do is we can sketch it, right? Using split into 3 different pieces. Let's start with the first piece, which is f of x equal to x minus 2. And the domain is x less or equal to -1. So we need, because it's a straight line, right, or linear equation, you only need 2 order pairs. But we're gonna including the endpoints here. The endpoints is -1. So we're gonna need -2 and -1. 2 points is enough. And then the endpoints here, these are the endpoints. This is what we call the right endpoint. Right? Right endpoint is a solid point, the solid one. Because there's equal sign here. So you're gonna find what is up -2. -2 minus 2, that is -4. Right? This is -4 here. After -1 would be -2. No, -1 minus 2. So this is -3. Okay. So basically we take care of the first piece. Okay, so we get 2 order pairs. That's gonna go. Yeah, 2 points here, -2, -4. First point, second point is -1 and 3. Okay. Now move on to second piece, right? It's a parabola, and then the overall shape is looking like this, right? So here's the parabola. Opens upward, but we just need to have endpoints. So one more time, copy the function. Then typically for the parabola, usually we need 5 points. But if you really not understand what the shape look like, and we're connecting with a curve, then 3 points, it's enough. It's okay. That will work. But remember to include those endpoints. So first left endpoint is -1. See that, but that's an open circle. Right? It's open circle here. What is right? And then also we're gonna pick 0 as vertex. That's where the vertex occurs. And then 1, right? That's right endpoint. And the right endpoint is the solid point. Something like that, right? Solid point. Okay. And yeah, so we're gonna start with all the y values, right? So after -1, it's -1 squared, adding 1, that is 2. You get that? After 0, that's a 0 squared, adding 1, that is 1. And that's 1. Okay. So that's a vertex, meaning it's the lowest point here. Right? And now problem, after 1, it's 1 squared, adding 1. It that turn out to be 2. So that will take care of the second piece, right? We can also get 3 points here. And third piece, okay, so still a linear function, right? A linear function here, straight line. Need 2 points. That's sufficient. Then, but an endpoint is needed. And 1 and 2, right? And this here endpoint is open circle. I'm gonna put a circle right there, right? Open circle. So after 1 will be 3 minus 1, that's 2. Okay. And after 2, it's 3 minus 2. It's gonna be 1. And yeah, so we're gonna go, right? So we can start sketching the graph. Use a different color and sketch a graph. Let's start with the first piece. Okay. First piece we have -2, -4. So we needed 4 points down below here. So -1, -2, -3, -4. That will cover everything here. First piece. Yeah, so the endpoint is a solid point, so that's good. So -1, -2. So -2, -4, solid point. -1, -3, that's also solid point because endpoint solid, right? So solid point here. Yeah, so we get 2 points connected, extended to the right to the left, right? So we get the first piece. Now move on to second piece. Second piece, -1, 2. -1, 2, -1, 1, 2. 1, 2 goes here. -1, 2. That's an open circle. Yeah. And then that's left end point. And 0, 1, that's solid point. And then 1, 2, that's a solid point. Right? So they're gonna connect it using a curve, right? Curve. Something like that. Something like that. That's a parabola opens upward. So we take out the second piece and the third piece. 1, 2, right? 1, 2 is open circle. However, it was filled by the second piece. Open circle here, but it's filled by the second piece. 1, 2, and then 2, 1. Here, now we connected, extended to the right. We get both points and 3 pieces. And if you look at this graph right here, is there any discontinuity here? What do you think? Anybody have suggestion? Discontinuity? Okay, so basically at -1, right? That's a jump discontinuity. So -1. At a -1, jump discontinuity. And that's only discontinuity here. Everywhere else is continuous, right? It's continuous to the left-hand side of -1. It's continuous to the right-hand side of -1. Okay. And yeah, so let's look at the limits really quickly. So limit when x approaches -1 from the right, So we're gonna go with the second piece, approach is -1, this is -1. There's a different color here. We go here, approach is -1 on the right, and then the y value approaches -2. So just put in -2. And second part, limit when x approaches -1 from the left. This is approaching -1 from the left. Then that the y value approaches -3. And these two does not agree with each other, right? That means limit when x approaches -1. Overall limit is not good. Yeah. And also, if you look at when x approaches 1, 1 is right here. If you look at the left-hand side limit, the y value approaches 2. And that's the left-hand side limit. And right-hand side limit, x approaches 2, right? So it does converge. So limit here will be 2. And then f of -1. F of -1, it's open circle here, it's a solid point here, so we have to use this. F -1 equal to -3. Okay. So that's basically how you sketch the graph and also analyze the graph to find the limit accordingly. Okay. Any questions about this? Nope. That's very good. We just put in the answers here. And the 2 and 3, 2 and 3. And then the 2, 3 here. And this is D and E. And approaches 1, that's 2, right? Yeah, 2. And F -1, that's -3. Let's do it. Submitting. Well, all good, right? All the answers are good. Yeah, this is 2 actually. Approach -1 from the right. I overlooked. This should be 2, right? I copied the wrong answers here. Approaches -1 from the right. Y value approaches 2. I overlooked. I copied the -2 over there. So the answer should be 2 and 3. Here, 2 and 3. So this is 2 and 3. Yeah. Submitted. It should be all good, right? All right. So that's question number 5. Number 6. And what are we doing for number 6 here? What is it about? Anybody remember?
For this one is the infinite limits.
Yeah, exactly, right? Infinite limit. Okay. And also infinite limit. It's a limit at infinity, right? It's a limit at infinity. Yes, the infinite limit. That's right. Very good. And an infinite limit is used to determine what type of asymptotes. Is it horizontal or vertical? All right, we have some of those vertical asymptotes, right? Infinite limit is used to test the vertical asymptotes. Yeah, so basically, you can look at each function here as a rational function. And then for rational functions, that's always vertical asymptotes. And why should we try to locate those and also try to verify the limit approaches either a positive infinity and negative infinity. So if it is infinite limit, then limit when x approaches c for function f of x will be either positive or negative infinity. Right? That would determine it is a vertical asymptote. So, but the sign does matter, right? So one of the most important things to determine the sign. So that's we have to analyze it a little bit carefully and without making mistakes. So let's look at it. So first part, x equal to 0 for this rational function. Again, it didn't specify the direction, right? Which means most likely it doesn't matter. That's why they didn't specify the direction. So either from the left or right, if you look at the denominator, we have x squared here. So from left or from the right hand side, after the square become positive, right? So on the bottom we plug in 0. And then if you plug in 0 here, 0 plus 7, that's a 7. It's 1 over positive 0 times 7. 1 over positive 0. Any number over positive 0 is positive infinity. Okay. So the answer here will be infinity. That's what we try to figure out, right? If you put a negative infinity, then it's wrong, meaning your analysis is off. Because this rational function, when x approaches 0, the y value approaches infinity here. And then if you look at this part 2, so for part number 2, now we are talking about analyzing the limit when x approaches 3 from the left, right? This is approaching 3 from the left. So what is this left? That means we're gonna look at the number as equal to 2.9. Infinitely many not. And then if you analyze it, top stays the same too, right? On the bottom, it's 2.99999 minus 3. And it's a very tiny little negative number. So putting negative 0. So again, plus minus is minus. 2 over 0 is infinity. So the answer for this second part here is negative infinity. And then the third part approaches 5. It doesn't specify the direction, so it could be either left or right. It doesn't matter because of the power to the 6. So after you're taking the even power, the denominator always remain as positive. That's why on the bottom will be positive 0. Then plus over plus is plus, 2 over 0 is infinity. So the answer here is positive infinity. And then the last part, we are looking at limit x approach negative 7 from the left hand side. It's negative 7, and then we're going from the left hand side here. And again, you're going to look at this number right here. This number here will be left hand side, that's going to be negative 7.00 with infinite many zeros in between. Right? And if you look at x squared, it's always going to be positive. Something close to 49. We even put in 49. And then if you look at x plus 7, this number adding 7 will be very tiny little 0, negative 0, negative 0.000000001 with infinite many zeros. So this is negative 0 there. And then plus minus is minus, so we end up with a 1 over negative 0. So 1 over negative 0 is negative infinity. So that's how we know this is negative infinity. So this analyzing part, it's important, right? Because although it's only 2 different answers, but getting the correct answers, it's very crucial to get full credit, right, in this problem. So, any question about this? Negative. Okay. So let's do it. That's all good. Okay. And so that's basically problem 6. And let's look at next problem, problem 7. And again, they're telling us, right, function to have this, it's supposed to have a horizontal asymptote if either limit at infinity exists or limit at a negative infinity exists. And we just try to confirm that. I'll try to verify that using the limit. Okay, so let's get to the detailed solution here. Yeah, so basically the way how I did it, right? I show you guys in the class when we talk about this topic is by keeping the leading term. You can basically you can do dividing, the entire function by the leading term in the denominator. For the first one, you divide 2x from both top and bottom, right? That's okay. If you want to do that. But what I try to do is I basically just keep the leading term on both top and bottom, because when x approaches infinity, only the leading term counts here, right? Everything else will become irrelevant, because compared to leading term, it's insignificant. On the top, we're going to keep as negative 8x. On the bottom, we keep as 2x. Now for the first function here, right? For the first rational function. Yeah, and then if you simplify, right, divide into that, you will end up with limit x approaches infinity, divide that to get negative 4. A limit of negative 4 is negative 4. And also this tells us the horizontal asymptote occurs at y equal to, right? That's the whole purpose. Try to identify where the horizontal asymptote is using the limit. And similarly, for the second question, keep the leading term on the top, and not x, that's the leading term on the top. On the bottom, leading term is x cubed. Drop everything else, right? And then analyze that. So limit when x approaches negative infinity. So this is just 9 over x squared. If you plug in negative infinity here, you get 9 over negative infinity squared, and negative infinity squared becomes infinity. So 9 over infinity, that's 0. So the answer here is 0. Also saying that horizontal asymptote is y equals 0. Or the other way of putting that is x-axis. Okay. And the third part, similarly, right? Keep the leading term to approach positive infinity here. So keep the leading term both top and bottom. So top is x squared, bottom is negative 4x squared. Leading term here, leading term, right? With a sign. So simplify x squared get cancelled. The limit x approaches infinity, it's 1 over negative 4. That's a negative quarter. So negative quarter is our horizontal asymptote. Putting a simple language, h, horizontal asymptote is y equal to negative quarter. That's the one. So answer is negative quarter. Okay. Any question about this?
So for the first one, where it says, negative 8x over 4 plus 2x, why do we get rid of that positive 4 on the denominator?
Okay, so positive 4.
Yeah.
Where do you see positive 4?
On the first one, he's asking about the constant.
Oh, the constant. Actually, we just dropped it, right?
Yeah.
So basically, this constant compared to infinity, this constant is nothing. It's like 0, right? So that's why we just drop it. Just drop this. And then we get this. And we can just get to the like dominant term in both top and bottom, and then find out the result from there. Make sense? Yes.
I'm still confused. What makes it cancel out though?
Oh, it's negative ax over 2x. You see, ax over 2x, that's 4, right? And keep
No,
the
like
signs.
why is the constant not important? When the variable is
Okay.
approaching infinity, why does the constant stop being important?
Very
Yes.
good. Thanks. You actually very good. You guys clean up. So let's try the textbook method. The textbook method goes like this. So the basically just dividing every single one of the terms here with 2x by leading term in the denominator, and you will see why. So if you divide negative ax by 2x, right? On top, on the bottom will be 4 over 2x, and then 2x over 2x. Now, if you look at it, what happened? Let's analyze. On top is negative 4. On the bottom is 2 over x. And this 1, right? Now, as x approaches infinity, 2 over infinity here. So this 2 over x, as x approaches infinity, will become 2 over infinity. That's going to be 0. That's what I mean, you know, compared to infinity, this 4 is irrelevant, right? Originally it was 4. But since our x approaches infinity, then this number compared to infinity as a quotient is like 0. And that's why I dropped it at the very beginning, because it's not a significant term here. The only significant term is this leading term here and the leading term here. And those two terms determine the end behavior. I think maybe using the textbook method, you know, you also get to that. So if you want to use the textbook method, no problem with that. Now, as you can see, this is 0, right? So you can negative 4 over 0 plus 1. It's negative 4 over 1. That's negative 4. Okay. Thomas, so do you feel better?
So do we only divide the like terms when it comes to the numerator and the denominator?
We only divide the entire rational function by the leading term in the denominator. In this case, the leading term denominator is 2x. Make sense?
Okay, I'm gonna try to practice with it. Thank you.
What if we looked at it using real numbers, sir professor? Like what if we
Sure.
what if we say like x is 100, x is 1,000, and show what it looks like when x is getting
Yes.
exponentially bigger?
Exactly.
That might show him better.
Yeah. Also, what if you just throw in infinity? That's even better, right? Let's throw in infinity here. So that's negative a times infinity and 4 plus 2 times infinity. As you can see, compare 4 to infinity, this is irrelevant. On the top, we get negative a infinity, right? A times infinity. On the bottom, again, we're going to drop this because it's irrelevant. So it's 2 times infinity. That's exactly what you're suggesting. As x gets bigger and bigger, then only those two terms matters. That's why if we cancel infinity, they also get a result. Right? If you put it like big number, a million, something like that, and we divide to that, you get approximately negative 4. But that's exactly what happens here. Yeah, hopefully this help you understand this slightly better. But yeah, so the reason why I only keep the leading term because only those two terms determines the end behavior of this limit. That's why we only keep the leading term on top, leading term on the bottom. Eventually, all the rest of the terms compared to the leading term, it's gonna be irrelevant or like insignificant. Just compare a number to infinity, that number is insignificant. That's the reason. Okay. Yeah, so that's basically answer for this one. So the first one is negative 4, right? Second one is 0. Third one is negative quarter. Great. Check it. It should be good, right? All right. So we we halfway through. Yeah. Okay, so question 8. So we are trying to use the limit definition of the derivative to find the derivative, but they want you to do it step by step, right? But that's also a good way to have something to follow, right? This is actually very good. They put in the scaffolding outline, right? So it just actually, I think it's just good. You can just go through this step one by one until understand the whole process here, which is so much better. Okay, so let me just copy the question. And just follow this guidance, right? There's a guidance here, and step by step. Let me share the screen with you. The guidance is also even give you this derivative of the definition of the derivative, right? You can just strictly follow this. Okay, so basically we are given this function f of x equals x squared minus y. And in order to apply the limit definition of the derivative, then you need to find what is f of x plus h. Again, we're talking about the same function f, right? Function does not change. The only thing changed is the variable. So we're going from x to x plus h. That's the change. So now meaning whenever you see x, it becomes x plus h. So the first term becomes x plus h squared minus 4 times x plus h. And basically you're going to expand it, right? Or if you, I think in the workbook, if you type in this, you get credit. But we're going to expand it. So it's x squared times 2 times h times x. So 2 times h times x. The second term. Third term is h squared. Second part is really, again, minus 4x minus 4h. Okay, so this is what we need, right, for this here. We take care of the first part. And the second part, since we have all of these terms, we're just gonna put this then basically simplify the numerator. Let's see what this is. So x plus h minus f of x. So we get this whole thing squared plus 2hx plus h squared minus 4x minus 4h minus f of x, which is c squared minus 4x. Remember, we're going to cancel f of x eventually, right? The whole thing. And that's how you know whether or not you calculation correctly done. If this two term is gone, both those two terms are gone, that means your calculation probably is good. Then we cancel in terms, right? So common terms in opposite terms is going to cancel minus 4x plus 5. And eventually we just going to end up with a 2hx. So this is 2hx adding h squared minus 4h. Next step, we're going to divide this whole thing by h, right? So 2hx adding h squared minus 4h divided by h. You can divide one by one, right? 2hx by h is 2x. H squared over h is h minus 4h over h is minus 4. And so that we end up with this quotient, right? It's called differential quotient. And so we finish that, we get this part, and it's all good. Now the last thing is to find out the derivative, right? So we just take the limit when h equals to 0 for the remaining things. H equals to 0, so we get this 2x plus h minus 4. And plug in h, you get the h becomes 0, so limit h equal to 0 is 2x minus 4. And compared to h, this is a constant. 2x minus 4 is a constant. And the only variable is h. So everything else is constant. So 2x minus 4. And that's actually a derivative, right? So since we already learned the differentiation rules, then x squared becomes 2x minus 4x becomes 4, right? It doesn't match with the. That's one way, another way to double check you have the correct calculation along the way. Okay. Any question about this? Okay, let's go back. I'm putting on the results one by one. And I see that, yeah, so this is going to type in h squared plus 2hx. So h squared minus 8, 4x minus 4h. And that will do it. Second part, remember these two terms gone. X squared gone, minus 4x is gone. So we end up with a 2hx. And then h squared. And then minus 4h. Yeah, so that's what we have. Yeah, it's good. And then the quotient, when you divide into that, it just becomes 2x having h minus 4. Right? And eventually we're going to analyze this. So front of x will be 2x minus 4. Okay. That will do it, right? So you guys can try it. Again, you're going to have your own version of the question, right? Probably different function. And you can try out one by one, step by step. And so you understand the process better. And next question is also similar, right? So we're going to do the similar things here. Okay, but it's a rational function, so it will look slightly different. Okay, so I'm going to just copy the question really quickly. And I'll follow the same process, right, like the previous ones. Okay, so we have this rational function. Then we have f of x. It's 1 over x plus 5. And then we also need f of x plus h. That means for that, x becomes x plus h. It's going to be 1 over x plus h. Then we take care of that part, right? Now that we can move on to the next part, which is what happened to, so this is part number 1. Part number 2, what happened to f of x plus h minus f of x. So we're going to have this 1 over x plus h. 5, first term, second term, 1 over x plus 5. And we're going to use LCD. These two terms has no common factors. So LCD here, it's going to be x plus 5. X plus h plus 5. So simplify that, right? So just combine those two. So for the first term, you're going to multiply by this factor here, right? X plus h, 5 times x plus 5. Both top and bottom, 1 times x plus 5. Second one is similarly, we multiply by the missing one, multiply by that. X plus 5 times x plus h plus 5. Top do the same thing. We multiply both top and bottom by the same factor. And if you put it together, you're going to end up with x plus 5, x plus h plus 5. The first one is just x plus 5. And minus, if you distribute this, right, it will be minus x minus h minus 5. And we're going to cancel a couple terms, right? We cancel x, cancel 5, and negative 5. So eventually this is kind of negative h over x plus 5 and x plus h. All right, so that's basically the second step. The third step is find the quotient, right? So step 3, we have this end result. Now you're going to divide it by, so basically we need x plus h, x over h. And we have the simplified version of the difference. So negative h over 5 h and divide by h. Now one more time, this is what we call a complex fraction. So we're going to do this to make it fraction on the bottom, right? That's how we simplify this complex fraction. So h over 5 x plus h plus 5. Now the bottom flip it, right? We divide. Division here becomes multiplication. Then we use reciprocal of h over 1, which is 1 over h. Okay. And this is important, right? Remember, when you deal with complex fractions, that's how we simplify this. And you cancel h, that's gone, right? So we end up with this negative 1 over x plus 5, x plus h, that's 5. Now, eventually, we're just going to analyze this. So limit of this, eventually, we try to find out this limit when h approaches 0. So it's going to be negative 1 over 5, and then x plus h plus 5. Now, if the h becomes 0, it goes in here, then we will end up with x negative 1 over x plus 5, and then times x plus 5. And again, limit, the only variable here is h. Everything else is constant. So limit of constant becomes a constant. So this is negative 1 over x plus 5. Yeah. So that's the final solution here in terms of the derivative using the limit definition. Derivative, right? So it's the end result. Okay. Any question about this? All right, so let's go back. The answers here. Start with f of x plus h, right? So it will be 1 over x plus 5. And then difference becomes a negative h over x plus 5 times x plus h, adding 5. Okay, I will do it. And third part, we divide by h, and simplify, it becomes negative 1 over x plus 5, and then x plus h, adding 5. Now when you get to the limit part, right, replacing h with a 0, then we end up with negative 1 over x plus 5 squared. So just check the answers. It's all good. Yeah. So this is basically question number 9, question 10. Okay, so we have this function here. You want to find the equation of the tangent line for this function at x equal to 2. So you can, so in terms of solving this, right, you can expand it, the functions into 3 different terms, right? That's one way to do it. Or if you like to use a product rule, since we already learned the product rule, you can also use a product rule. So again, I'm gonna keep the options available, whatever you guys want to do, right? Do it. So first of all, I will get a function here. So that's expanded x equal to pretend we don't learn product rule yet. We will FOIL this, simplify everything, and find the derivative from there. So adding 2. To FOIL this, we get 6 times 6x is 6 squared times 2, that's probably 2x. And 9 times 64, 6x is minus 54x. And 9 times power 2 minus 18. And combine like terms, right? The middle two are like terms. Combine them. Like terms. That's squared minus 52x 18. And from there, we can find the derivative by using the power rule, linear function rule, and also the constant rule. So 6x squared will become 12x. F prime of x here will be 12x. Negative 52x becomes minus 52. Minus 18 becomes 0, right? But we don't usually write that. So the derivative just becomes this. 12x minus 52. Then the slope of tangent line comes from the derivative. So if they tell us x equal to 2, right? Yeah, x equal to 2. That means slope of tangent line at x equal to 2 is equal to f prime of 2. So using the derivative here, replacing x with a 2. Get 12 times 2 minus 52. This is 24 minus 52. That turned out to be minus 28. Slope of tangent line is minus 28. And we still need to find out the equation of this tangent line, right? So we're given x values, but the y value comes from the original function. So third step is the x equal to 2. Then y value equal to f of 2. Go back to the original function, replacing x with the 2. So we have the 2 minus 9 times 6 times 2 adding 2. 2 minus 9 is minus 7. 6 times 2, that's 12, right? Adding 2, 14. Multiply this is negative 98. So coordinates x, y. So 2 comma negative 98. So I'll take out of part 3. Part 4 is using the point slope formula. Again, we know the slope now. It's minus 28. X1, that's 2. Y1, that's negative 98. I'll go back to the point slope formula. Okay, and then we throw in all 3 numbers, right? So simplify y minus and negative 98 equals slope is now 28. Times x minus 2. And distributed. So let's continue here. So y2 negative turn into positive 98. Here is negative 28x. And negative 28 times negative 2 is 56. And the very last step, just isolate y value. Minus 98 is 98. And that will do it. And so that's y equal to minus 28x. 56 minus 98, that's minus 32, 42, right? 42. And that's the answer for part 4. Any questions about this? Okay, so this is 12x minus 52 first step. Slope is minus 28. Point is 2 and negative 98. Equation of tangent line is 28x minus 28x minus 42. We never check the answers. Yep. That's good. Yeah, it's all good, right? Okay, any question about this? All right. Next problem, let's look at this applications here, right? We have a ball dropping from a height of 576 feet of the building or like object. The position function is given here, and we try to figure out the rest parts, right? Okay. So let's see. Let me just copy the question really quickly. In 1 second. Let me share the screen with you. Yep, so that's get to it. So step number 1, if you want to visualize it, right, just like what I did in the class, or like something like this. So you're dropping the ball from the top of the building here. So the ball goes here, and then the ball will follow the route. It's like a straight line, right? Usually it's like a straight line. And it's going all the way to the bottom, which is on the ground. So the route of the motion of this traveling route of this ball will look like this. Eventually, the ball comes down here. And the building is 576 feet. This is 576. We have the position function. So position function, let me use as of t. Let's hope this go back as of t. So 576, 16 t squared. As you can see, velocity function is the derivative of position function. So differentiating position function with respect to time t. Again, I didn't go with the limit definition of the derivative, right? We just use a shortcut, right? We're using differentiation rules. And it's a lot quicker to get all these derivatives. So derivative of 576 with respect to time t is 0. The derivative of negative 16t squared becomes 32t. So basically, we get the velocity function right away, 32t. Yeah, so that's basically negative 32t feet per second, right? So that's a unit for the velocity. And when velocity equal to 1 second, 2 seconds, v1, once you have the velocity function, just replace the t with a given number here, right? It's going to be negative 32.1, which is 32. That's feet per second. And the v2, so as you can see, in the process of dropping the ball, right, the velocity is getting bigger and bigger, right? Getting bigger on the line. Eventually, when the ball reaches the ground, the velocity reaches the peak, right? That's highest velocity possible. That's why the impact of the ball and in the ground is very fierce or very strong, right? Sometimes it is you may damage the ball, right? Or maybe crush the ball, something like that. So negative 32 times 2 feet after 2 seconds, feet per second, very, very high speed actually. If you we can convert the feet per second into miles per hour, right? And you can see how fast that is. I think it's probably over 100 miles per hour if you convert it, right? So it's very, very fast speed. And when does the ball hit the ground? So the ball hits the ground when the height is 0, right? So basically you're setting the position function. You're setting s of t for 0. We can solve for time t. So basically we get a 576 minus 16t squared. That is equal to 0. And solve for t. So basically, first of all, we just isolate. So adding 16t squared on both sides of the equation, and dividing 16 from both sides of the equation. So t squared equals 576 over 16. What is it? 3. Let's see. 176 over 16. Use your calculator, right? If you don't want to do it by hand, it's 36. So t squared equals 36, and t has to be positive 30, radical 36. Only take the positive time, so t equals 6 seconds. That means it takes 6 seconds for the ball to reach the ground. That's what this means, right? T equals 6 seconds. And when the t equals 6 seconds, they also want us to find out the velocity. Is that? Yes, velocity when the ball hits the ground. Okay. Velocity, so when t equals 6, then v of 6, it's going to be, go back to the velocity function, will be negative 32 at 6, right? So it's going to be negative 132 feet per second. Now I'm going to convert this. Let's see how fast that is. I'm also curious about this. So let's look at it together. Go to Google, maybe type in the negative 193 feet per second. Put to miles. You will see how fast that is, right? Usually we understand miles per hour better, right? This is like negative 130.9 miles per hour. So this is very, very fast speed, right? It's very, that's why the impact is actually very, very strong when the ball hits the ground. Yeah. Okay, so that's basically how we solve the problem step by step. Any questions about this? Okay, so let's put in the answers here. And let's put answer one by one, right? So velocity function is negative 32t. V1 is negative 32. V2 is negative 63. And t equals 6. And velocity is negative 192. When the ball hits the ground. Yep, they're all good. Okay. And the last question. Okay. So find the derivative of this function right here. Let me copy the question really quickly. Yeah. So if you look at it, we have a function here. One of them look like a quotient, right? A over x cubed. So basically, we're gonna convert it a little bit. We'll turn into the power for the first term. So f of x should be equal to, flip to the top to get a times x to the negative third power adding x squared 14. Then we find the derivative using the power rule. So although negative power, no problem, right? We just treat it as a power. And 3 goes in the front, reduce the power by 1. Second term becomes 2x. Third term becomes 0. Okay. And we just simplify afterwards. 8 times negative 3 is minus 24. This is x to negative 4 power 22x. I'm just going to simplify a little bit more, right? We don't want the negative powers here, so it's minus 24 over x to the 4 22x. And that's the final answer, right? So it's minus 24 over x to the 4 adding 2x. Okay. Do you have any question about this? Again, when you go back home, right, later when you finish the class, you can basically review the questions on your end. You have your own version, try that, That's how you know if you really understand this, all this solution here. Okay. Good. Yeah, good answer. Okay. All right, so that's pretty much everything. That means your exam number 1 will have 12 questions. I just put 12 here, so your actual exam will have 12 questions. And again, as I mentioned, it covers from 2.1 all the way to 3.2, right? So it's about 8 sections of the work here. I didn't put any question from the review section 1.3. I didn't pick any question from there, just those 8 sections. Now, we're gonna take a look at, I'll just do a quick lecture, just get started on the chain rule, right? So in the old textbook, it's on the section 3.5. Let me share the screen with you. But the chain rule applies to this particular function called composite function.
Excuse me.
Yes.
Sorry to interrupt. Will there be the Zoom meeting posted after class? Like, will this recording be posted on what is it? Blackboard?
Yes, I will post this, right? That's why I recorded video for today's lesson. And
Thank you.
I'll post it as soon as we finish. I will start producing the video. Let me see if I can get a YouTube video. I may be able to get a YouTube video. I will send it to you directly to your email.
Thank
so
you.
We can review this over the weekend. Okay, no problem. But it's a good question, promise. Okay. Yeah. So let's take a look at the chain rule, right? Section. A little bit too. Font size is a little too big. So let me just quickly adjust that. Just change the size a little bit. This size is good. All right, so section 3.5. And it's on a chain rule. Okay. So the chain rule applies to a composite function. You guys remember the composite function? So I'm going to give you a comparison, right? Regular function. You will see the difference between the regular function and the composite function. For example, let's say we have something like the original function that is x squared minus 2, right? This is a regular function. So what a composite function look like? Will be f of x equal to square root of x squared minus 2. So now this is the original function, right? Original function, regular original function is second degree polynomial function. And a composite function becomes a radical function. So what two functions give us the new composite function? What do you think? Anybody have a suggestion? Okay, no problem, right? Okay, so basically you can look at this. Let's say f of x equal to radical x and g of x equal to x squared minus 2. And remember, we learned a composite function. How do we composite? Find the composition of f composite with the g. So let's say, how do we end up with f of g of x? So you go back. So this is basically still based on the function f of x. Now you go back, replacing x here with a given function g of x, right? So this x here becomes this element. It goes in here. So you end up with x squared minus 2. So this new composite function is a composition of two functions, f of x and g of x. Okay. So that's why this chain rule, it's mainly used to find the derivative of the composite function. So obviously, composite function is a little bit more complicated. Right? That's why we gotta use a special rule, like chain rule, to find that. But you see that in a second. Let's say g of x, another function is we change maybe colors. Let's say 4x plus 3. Yes. And then the composite function will be g of x will be 4x plus 3 to the third power, something like that, right? So this is the original function. Now we get a composite function. Now, if you want to follow the same logic, right, to find the composition of this function g of x, will be f of x, will be g of x here. I mean, you can use any other variable here, so will be g of x. Anybody have suggestion?
Wait, is there three bracket for x plus 3 to the power of 2
X
and the derivative of that?
derivative of that.
Yeah.
Yes. Okay, I've seen that, right?
Yeah.
So, okay, so you mean you're suggesting that find the derivative from there, right? I think it is a little bit ahead of time. So we just try to break down like what will be the f of x here, what is the g of x here, in order to have a composite function of this function here.
So f of x is gonna be parenthesis x squared minus 2 to the 1 over 2. To factor, I'm just making it much more easier.
Okay.
So
Well, let's
x,
see. Sure,
x
go
squared
ahead.
minus 2 to the f power, and g of
Ah.
x is gonna be,
Okay.
I'm just wrong,
Okay.
I don't know.
Okay. So you are trying to find the derivative. We're not up to that step yet. So we just try to break down this function, right? So f of x will be x cubed, and then g of x will be 4x plus 3. So if you do f composite of g of x, what do we end up with? Meaning for function f of x becomes this. So we end up with the 4x plus 3 to the third power. Does that make sense? So we try to break down into two elements, right? F of x, g of x, for any like composite function. So this is a typical composite function. We can always break down into two, like inner function and outside function. In this case, the inner function is 4x plus 3. So whatever inside of the parentheses is called inner function. And then the outside function is x cubed. And we are putting these two functions together, right? That's where the composition comes from. Remember in the pre-calculus, you learn how to find the composition function of two given functions. And that's exactly what we're doing here, right? We just try to break it down into two functions, two basic functions. And then third scenario could be h of x equal to another function. Let me think about it. Something like this. Let's say 2x. The h of x is 2x minus 1, something like that. Right? I mean, this is the original function. The composite function could be h of x. Two x minus 1 raised to -1/3 power. And again, one more time, let's see what are those two parent functions here. What is f of x, what is g of x in this case? Anybody have a suggestion? One more time, for h of x, right? In order to break down h of x, the inner function, okay, inner function is always function inside the parentheses. So f of x in this case, g of x, we know the inner function g of x is 2x minus 1. So then the outside function must be x raised to negative 1 third power. And if you do composition, right, f is composite of g of x, and this will become, so this x becomes 2x minus 1, so it becomes 2x minus 1 to negative 1 third. So what I try to do here is break down all these different functions and show you how composition function works. Then we will know how to differentiate in those composite functions, right? So I'm going to give you one more, right? Let's say y equal to 3x, something like that, right? This is the original function, and then composite function will be y equal to sine of x. So this is again, it's a composition of two functions for this one. So what is f of x? What is g of x? So the inner function here is 3x plus 2. And f of x will be sine x. We are find the composition of those two functions. So in the f composite of g of x, it's going to be x becomes this. So it's sine 3x plus 2. That's how we get all these composition functions, composite functions, step by step, right? And those are the background information, right? It's like something you learn from pre-calculus, and then now in the calculus, using the chain rule, we try to find out the derivative of all the composite functions, right? That's our goal. Let's find out how we differentiate in those. And so that's, let me give you the theorem behind this, right? So chain rule. Let's look at chain. Again, chain rule applies to composite function. Okay. And then chain rule goes like this. Let me quickly show you some algebraic transformation of this dy over dx. We start with dy over dx. That's basically the derivative of the function, right? Of the function y, or like f of x. What if you multiply both top and bottom by du? Meaning multiply du here. Erase it. We can do that, right? We can multiply both top and bottom by the same term. That works. So we multiply du here, top, du on the bottom. Now, basically, and once you do that, now we can split into two terms, two quotients. First one is dy over du. So dy over du goes first. I just rearrange the order, right? And multiply by du over dx. And here, the thing I create is called an inner function. The u here is what we call inner function. So basically, we differentiate in two parts, right? We differentiate in a function with respect to inner function u, and we differentiate the inner function with respect to. So chain rule has two steps. Step one, differentiating the overall function with respect to inner function u, and differentiating inner function u with respect to x. Right? That's how the chain rule works. So you can remember this really quickly. And also equivalently, so this is equivalently, if you're using the function f composite of x, so it will go like this. F composite of g of x. So composition. So we're dealing with all the composite functions, right? Composite function is always composite into this, right? F of g of x. So we're differentiating outside function first. We get f prime of g of x. And multiply by derivative of the inner function, which is g prime of x. So it's a two-step procedure. Any question about this? Again, this is very important, right? Next step, next class, next section on increased differentiation and related rates, all dealing with the derivative. We all using the chain rule to deal with the different kind of applications. So increased differentiation application, related rates, also the application of the chain rule. So now, let me just, yes, Angelique, you have a question? Yeah.
Can you hear me? Am I okay?
Yes, I
Okay.
can hear you.
So when it comes to this rule, when we differentiate the outside is f of g of x, the outside wouldn't be f of x?
So the outside is f of x. That's right. This is the outside function.
Okay.
Yes, and the inner function is g of x. So I have
Okay.
two layers. So no problem, right? I'm gonna go over the solution for each one of these. Let's see how we apply the chain rule to differentiate each one of these. Since I already created questions, let's get to it. Maybe you feel better about it.
I was asking like specifically for the when you scroll down the rule, the dy over dx.
Yeah. Okay, dy over dy over dx.
Yeah. So why isn't it f of x prime times g of x prime?
Oh, I see what you mean. Just different notations. You see, they are the same basically. They're talking about the same thing. One of them is using the dy over dx notation, right? The other one is just purely using the f of g of x, the composite function itself.
Okay.
Yeah, so basically, it's just like two different ways of writing the chain rule. That's all.
Okay.
Thank you. I will close the gap. Don't worry. In a second, I will show you how to look at chain rules from these two different perspectives. That's what I'm going to do right now. Okay, so I'm going to take in the function. That's a very great question. That's a great question, right? So question one, remember we have let's find the derivative for find f prime of x, given that f of x equal to this, let me see, wait, that function on top is a square root, right? Square root of x squared minus 2. Square root 2. Now, if you're taking using the first approach, you can look at this as first approach, a second approach. If you're solving the question from the notation number 1, now you're going to create an inner function here, right? So we're going to use the u. It's having u equal to inner function. Inner function is x squared. It's a function under the square root. So what do we have? Right? And what's going to be du over dx here? Anybody have? Okay. No, nobody want to ask. No problem. So x squared becomes 2x. Derivative negative 2 becomes 0. Right? We get that. So basically, we already complete half of it, right? Because du over dx right here. And we just need to find out what's dy over du. So you can look at this as y. This same thing as saying y equal to square root of u. Then that's y equal to u to the half. right? Now, what is dy over du here? Based on this, so dy over du is going to be using the power rule here, right? So we're differentiating the variable y with respect to u, and it'd be half goes in the front, reduce the power by half. So this is basically half times u to negative half. We do know u, right? U is this. Okay, so this basically becomes half u is x squared minus 2 raised to negative half. So this part, this portion is called differentiating the outside function. This is differentiating outside function. What is the outside function here? It's a square root function. The outside function, right? Differentiating outside function. And this part is differentiating the inner function. This is the inner function. If you put it together, right, we try to find f prime of x. The same thing as saying dy over dx, just different notations. Then we have dy over du, right? Here, dy over du is this. Then we have du over dx. Is this. I just put it together, you get a result. So this is going to be dy over du, that's half times this x squared minus 2 to negative half. And then du over dx, this is going to be 2x. Are you guys following so far? Okay, any questions?
It's still kind of confusing for the second part. Like, I understand that the second part, the dy over the du, is the outer function.
Yep, that's right.
But
so
when you put it together, that's where I'm lost.
Okay. Remember, I just showed you how to go from dy over dx to dy over du times du over dx, right? Do you understand that part? How do you
Yes.
go from dy over dx to dy over du times du over dx? Basically, if you cancel du here, right? If you go back to the original expression, like dy over dx. So basically, just like the proof we showed yesterday, right? We subtract a term, we add a term. It looks like nothing changes. If you cancel them, it's gone, right? But it does serve a big purpose here. Same thing here, we multiply du on both top and bottom and rearrange it. During the process, we create an inner function u. That's why we don't cancel du, right? It stays there. So right here, we break down into 2 steps. First step is just first of all changing f of x to u to y. They are equivalent, right? Y is f of x, same thing. We just change it from function notation to standard notation. And we're assuming the inner function is x squared minus 2. This thing becomes this x squared minus 2 becomes u. And we basically convert it, so this becomes outside function. So y equal u to the half. So we do dy over du. We're differentiating the variable y with respect to u. And this is a power, so we apply the power function, power rule, right? Apply the power rule to the power function, half goes in the front, reduce the power by 1. Then you simplify, you get half times u to negative half. Now, since we set u equal to x squared minus 2, so this u becomes x squared minus 2. So eventually, the outside function, the outside function becomes this. And this is also what we mean by dy over du. And for du over dx, it's a lot simpler because u equal to x squared minus 2, right? So differentiating the function u with respect to x, then x squared becomes 2x. Negative 2 becomes 0. So you put together the second part, which is the derivative outer function. The inner function. And so if you multiply those two elements, right, dy over du times du over dx, we have the final result, which is the derivative of the composite function f of x equal radical x squared minus 2. So we cancel half right here, we cancel half and 2, right? And we can turn into a fraction and keep the x on top, and then flip the negative power to the denominator, get x squared minus 2 to the half. So that's the final answer here. All right. So basically, let's do one more, right? Let's do g of x. Let me just show you how to differentiate this. Oh, by the way, I can also show you how to, if you just do directly as a composite function, d dx. I should show that. That means we are, so the rule is f prime of g of x, right? Multiplied by g prime of x. Now, f prime of g of x is like taking the square root of, so this part is find the derivative of square root of x squared minus 2. Yes. And the way how we do it is, first of all, turn into a power function. So it becomes x squared 2 to the half. The way how we differentiate it is just the outside function, and it will be, this becomes half goes in the front and reduce the power by 1. Half minus 1. Right? That's exactly this right here. And if you simplify a little bit, minus 2 to negative half. You see, that makes this connection here. The same result. We take care of this f prime of g of x, right? That's right. And g prime of x, because g of x, so g prime of x, g of x is inner function. The inner function here is x squared minus 2. The derivative of x squared minus 2 is 2x. That's g prime of x. So basically we get the result. So this is g prime of x. So they will bring together will be half times x squared minus 2 half times 2x. That's exactly what we have here. We simplify and end up with the same result over x squared minus 2 to the half. Same result, right? But this one, we probably need a little bit more thinking before you doing the derivative. And using this u substitution method, right? By creating the u, it's actually slightly easier to understand. Right? Just follow the procedure. Just split into 2 steps. Find the derivative outside function and derivative inner function, multiply them together. Well, I think I will stop here today. Right? So you guys can, I will continue talking about this on Tuesday, right? Next Tuesday. And we go back to the in-person class here. Most likely we're gonna have an in-person class on Monday, right? Yes. Yeah, you're gonna take the exam number 1 on Monday is in person, right? I sent you. Yeah, I'm pretty sure by Monday everything will be okay. So we're gonna meet up on Monday in person. You guys taking the exam on F507. Okay. And so I think I will end the class. And do you guys have any questions before I end the class? So again, I will post the video, right? Produce as a YouTube video. I will email to you guys later. Okay. So have a nice weekend, guys. Bye.